Hi all, welcome to the next version of Amnic Cast. Today we are doing a different format with Sathish K S over here, and today we are going to talk about building highly scalable, available systems for data resiliency. Before that, let me put the disclaimers. Our panelists will be sharing their personal views on this one. This is nothing to do with what they have done in their what they are attributing back to their companies. Everything that's being said in this platform is towards their personal opinion, right? With that, welcome Satish.
Thank you, Sathya. Thank you for having me here.
Awesome. So I have known Satish for close to a decade now. We
Yeah.
both probably started working very long back, and then each of us went our own way. So happy to have you.
Yeah.
And then
Same startup way, I guess. So,
so and you have had an amazing journey, right? You started off at TVS, and for those of you who don't know TVS, it's like he was part of building a motorbike in their quality team. From there, actually had a journey on the data, and then come a long way in terms of building data products, right? Like, why don't you take you through the journey, take the audience through the journey of how you started off, what made you switch to the data side, and where you're.
sure. Um, so, since you mentioned TVS, I just need to give one highlight which came out of TVS when I was working there. I fortunately started with a team called the Total Quality Management. So, they were managing the entire quality, not just of the production, but something as simple as what is the food quality being given in the canteen, and what is the shoe quality being provided to the employees. So quality was like the apex team there.
Okay.
So that is one takeaway I still have, which I all the way to the even current data journey, which I still have that as one of the key teams to deliver something really good to the customers. And you know how TVS protects them. Then the classic bug, 2000, early 2000 bug of moving to software caught, and I moved to software, started with services, and it was a classic delivery company. And that gave me certain experience in terms of how delivery-oriented projects work for international clients. Then from there, I had probably my first deep development stint was in BA systems, WebLogic server.
Yeah.
So I started with the integrations team, then moved into the core server. And I would say at that time, I couldn't relate it to data because data at that time only was data warehouses. But in BA, I happened to land in the JMS systems, so Java.
Yeah, I know.
And believe it or not, at that time, breaching 8,000 RPS was a big deal. So I still remember the project name. It was called the Project Clipper. Clippers apparently a ship which set the first record of transatlantic for speed.
Okay.
So that was the project name, and we managed to cross the 8,000 RPS. In terms of measuring speed. Then after Oracle takeover, we just looked at the opportunities and moved to Cisco. And again, Cisco, it was a fledgling team. They were building what currently is called the classic IoT stacks. At that time, it was called the Smart and Connected Communities, for want of a better name. And there is where I would say I was introduced to data. Now it's called data ingestion. At that time, we used to call it the data collection framework. It was not a platform, nothing, none of the fancy word. It was called data collection framework. So you had to collect data. So imagine this scenario. You have close to 150 odd buildings. Each buildings have approximately 5,000 different data points of power, your motion sensors, your HVAC systems, and all these things. And each will have a variable way of emitting each of the signals. You need to collect it and put it in a database. And weekly, somebody would analyze that and take some decisions to adjust things for the rest of the week. This is for the LEED green certification, if you don't know. That's the green building certification. So I happened to join that team and start working that data collection framework. That project fortunately came to me. And my foray into data started there. It was more of a fortune plus serendipity rather than by choice. So that is the way I put it. And but in retrospective, I believe that is one of the best things which has happened. It gave me a good insight of what it means to be more data driven in And that carried forward. The startup bug caught up with me pretty late in my career, I would say, after my mid 30s. And when I was looking at multiple startups, Ola was a hot startup at that time. I joined the data platform team. And one of the major experience in Ola, which I would like to call out, is data platform is one thing, but how you build a product in top. So you need to solve a business case. Basically.
Yeah.
So that experience came in. Again, it just happened as this thing, as an outcome of what we had built. That was a fraud platform. Then Zeotap happened. By that time, the startup bug probably hit me the same way it hit you. So I thought, let's look at a 0 to 1x journey. And that is how I jumped into Zeotap. That is a like there is a statement, right? In many companies, data platforms is side business. Either it works or not, it's okay.
Yeah.
Deliveries go on. But Zeotap, that is a bread and butter. Data platform, data products, bread and butter. So that was one of the main draw for me. That's where.
So amazing journey. So I think I'm going to compare and contrast a bit over here because I went through very similar journey. I've used via WebLogic days back, and then I can relate to JMS. But most of my career, I was in the processing side. So from JMS, I know from JMS, how move to Kafka, how the data processing, Spark, and all those things. Now, when we come into data processing, even at Ola, it was mostly processing part of it. We were in the data platform, right? So when you talk about resiliency, the system world, okay, your systems can't go down, right? Or you save the data and the data can't, it has to be highly available. And in the database was called your data needs to be highly available, even if a zone goes down, it still has it, right?
Right.
How would you define that in the data?
Okay.
So I know you have a very interesting thought process into it, right? How would you define that, and what would it take to build something of that sort?
Okay. So starting with the end of the question, what it would take, of course, there are some principles which is applicable to all the domains. But one of the major thing for a data platform is always be on with the business context. So that is the, I would say, underlying you should start with in terms of building. Now coming to the resilience story, you rightly pointed out system resilience is seen from a, I would say, application and infra lens in terms of availability, uptime, and if you are able to, the systems has a redundancy behind it and all these things. But when you put a data-centric lens, the application-centric lens brings in this classic utilities, as we used to call it in old school, right? All the non-functional requirements. But if you are building a data product, just think about it. Suppose I am creating data API. Just a small differentiation. Order API is not a data API. Right? You just give an order, the order gets processed. Whereas a weather API might be called as data API. So one of the biggest differences, these APIs are homogeneous in content. Okay? The other one is more heterogeneous, and this is typically accompanied by a catalog. Okay? Now, the API might be up because your gateway is doing fine, your Cloudflare is fantastic, Nginx is in all up and flying. But what is happening is you want to, let's say this is Christmas season, you want to dole out coupons based on some criteria which you have given to the data. You want to get a cohort of users, okay, to whom you want to dole out discount coupons. Now, if the API responds HTTP 200, and ideally it should have sent you 110 users, it sends you 2 users for various reasons. Let's get into the reasons later. Would you consider that as the resilient experience?
No.
Right? So this is where the importance of something called the data ownership of how an engineer looks into it. Right? That comes into play. And how do you put systems to ensure this flow of data is happening? Since I alluded to the flow of data, another major way of looking at a system, transaction system versus a data system is transaction systems are more vertical in nature. Some user comes in, he does something, he gets pretty much universal. This is the okay. There might be sync, async, all these concepts, but data is typically horizontal. Somebody will do something here, the benefits would be extracted in multiple layers by someone else. Okay. And somewhere something changes, 4 of the ecosystem would be still operating fine, 3 others would have gone. Okay. So that is a more horizontal end-to-end view. Typically, that's why all data platforms, you call them as data pipeline, workflow, all these are interchanged. So the flow, how you manage the flow is super important when you think about the data platforms.
Yes. And how do you validate it? Now you have built all these things. Do you have a framework to make sure that I can, and again, from your quality background, right? Everything has to be perfect, right? How do you actually build it to make sure, okay, I did everything, but it's the final data is correct, right? What do you do to do that?
Right. So that's a very deep question, Sathya. So we had this movement in testing. Okay, I'll start with pre-deployment. We will come to the post-deployment. Pre-deployment, you have the classic testing methodologies as part of your SDLC, be it extreme programming, agile, or anything. So data product testing is as good as building another small data product. So you need to be extremely aware of the what I call it as the input and output checkpoints and how exactly you check the shape of the data which is coming. Okay. And if something changes, you need to figure out what is the impact analysis on the multiple touch points which you have.
Correct.
So the testing framework itself has to be built in a little different manner in terms of how you're going to. You need to have point input output with all the variances. Say, for example, a classic example which I have seen is many times the client they'll say, "I'll send you CSV." The C is interpreted to be colon, semicolon, whatever,
Correct.
and they'll demand, "Oh, CSV I'll send with delimiter pipe." Now you need to kind of protect your system from all these, right? So that is a kind of an input output this thing creativity which you need. Okay, and this also comes in terms of how you figure out your boundary conditions. Okay? So typically all data products they have to coexist with your ecosystem. It is not like it is going to ground up work in scratch. No more the case in any enterprise. If you're going to go and put a data product, be it observability tool or AML tool, MLOps tool, whatever, it has to coexist with the existing systems. So you need to be aware of the supply chain and how do you test it. So the testing framework itself needs to be highly creative, both in terms of the matrix of dependencies and in terms of the input output. That is pre-deployment. Now, coming to the liveliness when your system is live. One of the angles which I would say general application would look at is the uptime in terms of creating redundancies. And there is this, you are very well aware, even in the DevOps, which you guys are trying to develop. Overload protection is a very important thing. Now, overload protection, the typical way of looking at it is looking at the volume. Okay. The classic question would be, hey, suppose you are doing SR interview. Pretty much the universal question would be, tomorrow load is 10x. What will you do? Okay. Whereas for a data product, beyond that question, what you should ask is, today Parquet is coming. Tomorrow suddenly Agro has started coming in. How will you catch it? So that is called a variety angle. The 4 B's of data, as we call it, right? So you need to make the system resilient for the variety, for the various reasons which I told. Because you are coexisting with the ecosystem. The user will interpret something as himself, whatever he intends to. So how do you protect? So this is another thought. There are various patterns. Say you can create a validation filter, you can create alerting system. That comes later. That comes as part of observability. Once you identify all these, then you, in the end, you kind of amalgamate all this to the observability tools. Okay. So the overload protection from a variety angle is super important. Volume angle, everyone thinks through. Okay. Then the third thing is resilience. One of the important thing is many people they like hoarding data. Okay, and pretty much many of the enterprises you will see they'll do a complete snapshot processing. And the typical way of taking pride is, oh, I process 60 petabytes of data per day. Is it necessary? So that is where the housekeeping thought process comes. Okay, the timestamp and the data is very related, interrelated. Many times, for many active things which you're doing at this point in time, you need not process that much. So you need to be very, very use case centric, so that efficiency is across the entire platform. Okay, because the more petabytes you add, you are just increasing the processing time, or you kind of break down, divide and conquer. That means you are increasing the number of processing stages. The more you do this, the more resiliency problems is going to create, because each one you need to add the additional one. So that is something we need to be aware of in terms of housekeeping. How much you need to keep in cold, how much you need to keep in hot, how much in warm. So this layering is super important in terms of the resilience. So these are all additional aspects beyond the classic uptime which we do, right? Which is important for a data product.
And how do you get into this thought process? I see Amnic has been looking into multiple customer stuff where, like what you said, the data is there in S3, data is there, but they don't think like, do we need to process this much data, or should I archive? Until you ask. Now we ask for the cost part of it, so they, I can archive this, or I can move to a different tier. Right? But how do you bring the thought process itself in terms of, hey, what's the data for this housekeeping? Right? Is there a thought process that people can go through to say, how much of data do I need actually?
Brilliant. So this is where the data team needs to work with, say, the product and the business closely. Okay, because engineers, by their motivation, they like to expand this processing day. Okay, so it is not like they want to reduce; they want to increase on a day. Let's take some live examples. Say Ola, there was a fraud prevention. So if there is a fraud prevention system, okay, the fraud, there are two angles to it. Okay, suppose you're doing an AI model. Okay, so you could take a threshold of past so many months of behavior and figure out whether he is crossing that threshold. Okay, suppose you are attacking with a heuristic model, saying that this driver, this or these three combinations should not come into my system. If these three combinations are coming, then it is a fraud. Okay, this is more or less real. Okay. Now, first one, you understood that I need to just cross that threshold, beyond which I don't need to process other data. It will just move my needle by another 0.5%, which doesn't make any sense. Okay, so you need to know at which point it is moving. And beyond that, that data is not needed. Probably you can use it for a reconciliation as an audit process down the line. Say once a year you try something and say that, hey, these are all my models. Right? So that is second thing. In real time, if it is there, many times what people do is all the real time thingies instead of having a very simple lookup, or even a probabilistic data structure. It could also do the job. Right? So you need to have this. Once you know this is the thing, you start thinking in these dimensions in terms of, first and foremost for housekeeping, the time dimension is super important. Second thing is the data literacy. What is the data you're playing? Right? The data literacy and time dimension goes. And I might be touching the time dimension again and again. It's super important in any data product. Okay? Because the time value of, just like money, time value of data is the more recent frequent it is, the more valuable it is. So that is these are the initial dimensions that I ask people to think of. One is the time, and one is the catalog or the schema of what they are handling. And the other thing is, of course, right, that you might need only people who have done model training and all these things. They'll figure out, they'll come to a feature engineer and figure out of 100, only 5 is needed. Right? So the remaining 100 can be just kept there in some most compressed S3 storage and just leave it. You know, the cheapest form of storing it. You need not process. So that is where you have to really co-work, and data leaders have to enable it. They have to inculcate as a culture, and this culture of I would say I'm processing the maximum amount of data. It's not needed.
So I'm going to switch some gears into, okay, you walk through in terms of the process part of, like, this is how you should think, this is the housekeeping, right? Let's go deeper into, if you want to build this kind of system in today's world, what are the pieces that you would put together?
Right? Okay. Sure. In today's world, one of the first and most important thing which people have to be aware of is governance governance aspect. You need to have a clear governance because almost every country is passing governance laws. India passed the DPDP bill and the GDPR came in, and we were one of the initial users of GDPR as well. So that aspect has to be thought through. So that naturally brings in a certain level of what do you call it as clarity in terms of how you are going to create your data structure. Okay. Second thing is in terms of what are the other aspects of this thing. Definitely in the current paradigm, what happens is the storage and compute, they are try to be as separate from each other as possible. You don't try to squeeze together. So always look at paradigms which could decouple these, and this gives you lots of benefits. Okay. And don't jump into streaming just because streaming is a cool thing. Many times it may not be needed. Okay, so just ensure you don't spend too much energy is on setting up a big Kafka cluster, managing it, and doing. Of course, Confluent is that manage it, but whether you really need it, that is. So streaming versus batch is a common paradigm which you need to figure out, and you could have that kappa kind of architecture where batch is unpacked into a stream that is efficient, but I'm saying talking about the real streaming, right? Where you do a OLAP use case itself. You have the OLTP and OLAP constructs. The batch to stream unpacking is a OLTP construct. Actually, it is not a OLAP. So the OLAP construct, people try to do streaming on day one, which might be unnecessary many times. So the first use case which I told, right, the IoT use case, many times they will do analysis only once a week, and the analyst will be two people. For once a week, why do you break your head in creating an end-to-end Apache, Kafka, and all these things, right? Unless it is going to reflect real time. And the other things in the modern data stack which has come is the SQLs has become super powerful. So the extract, transform, load paradigm has moved a good number into the extract, load, transform paradigm because let's face it, right? Even today, if you talk about data engineers, the first interview they go through is SQL, right? So SQL, by far, it is one of the most powerful and most used. It's not like you're going to check all that. Even today, analysts everything is like that. So the ELT paradigm brings a certain level of organizational flexibility in terms of deploying something called the schema on read semantics as and when you need. Okay, that is primarily needed for ad hoc reporting and these kind of capabilities, where schema on read people would be the right people. If it's a core business use case, then you look at the real-time tools, and suppose you want, as I told you, discounting coupons and other things, or you want to target in real time, or you want to create a location-based services, or you want to have a alerting, weather alerting service. These all happens more or less in a real-time basis. So that you spend those tools. So broadly, I would say you have the storage stack, you have the processing stack, then you have the metadata stack, okay, which is now called the data catalog. There is a huge movement.
Correct. Yeah.
Then from the governance stack, you have a couple of access tools, PI management tools, privacy management tools. Then you have something like the classic audit tools from there in terms of who's accessing the data, who's the one of the data, and other things. So it's a whole stack on its own in terms of what you put through. So governance is something where people struggle with. At least my personal suggestion is look at tools in the market because it is not easy to build. Because it is quite a complex thing to build governance. You might spend like easily 2 years building a proper governance system. And there is I would say, I have in one of my talks I have given, it's like a 8 to 9 step hierarchy in terms of how the maturity levels you reach there. So that is something I would say better invest on a tool and get it done. And get the government audits, everything done, rather than break your head inside. This is what it is. If you have anything, double click on this, or if I miss something.
No, I think this looks super good. Let's go into the use cases part of it. In terms of, you talked about fraud as a use case.
Yeah.
What are other use cases that you have done on these kind of systems?
So we have done, of course, ad tech, and we are heavy on. I've done a bunch of martech use cases as well. And as I told you, fraud was one use case. Then prior to that, there was a use case where the growth engine was consuming to send the discount, on-spot discount coupons and all these things. So there have been multiple use cases, but each have been a little different. And IoT use case, as I told you, right, to manage the power consumption of the system.
Yep.
Each of this, if you have to break it down, each had a completely different paradigm. So IoT was heavy on rights. In the sense you had to, because everything is emitting, you somehow had to catch all the data and put it, and or do a mini aggregate and other things and put it for the analysis part of things. And it was very low on rate. Fraud was quite challenging because it had both the use cases, which had simultaneous, you could say it was a simultaneous read-write system. So there we did deploy real fast lookup KV stores to help us. And I would say we came up with the team came up with a very beautiful entity model in terms of how it should operate. And that I would like to touch upon it because that is something you could universally apply in many cases where you want a policy engine. So fundamentally what we model is a policy engine of sorts. Okay. So you have event or a data point. Okay. Generally what happens is it could create a trigger because of some value it is happening or because it is aggregating to some value which has happened in the past, or it is a type of event which is coming in. So these are three things which can happen. Right? There is a type, or there is a value of a certain thing, then there is the aggregate of all the past values. Okay. So that is the first thing, the event entity and these three. And the second entity is the trigger entity itself. The trigger will go and say, hey, this has happened. Okay. Once a trigger happens, what happens is there is something called a rule evaluation engine. So that we could model the rules. Okay. So the rules could say that, say past 7 days, if some person is performing X activity, then do this. This is how it is. Okay. Now I'll just break it up. So the rule is the English grammar. You had two variables there. X activities. That is a threshold. Okay. Threshold was taken. Do this. That is the action. Action can be anything. Action can be call this API. Or action can be alert the alert. Or action can be send an email. Or action can be do block someone, right? Or call the police. Anything, any action. So all these became separated. So what is the flexibility of the system which was given us? Tomorrow, this threshold, you can use a model to train it and adjust the threshold. You can start with heuristics, then it becomes. Right? Then the rule becomes a basic English there, which is connected to the event and this thing as a trigger. Okay. Same kind of system, which we again put it into use into a ad tech. If you think about it, this is like a SQL in a morphed manner, right? You're just creating a filter criteria and other things. Just that the criteria is like made much more flexible. So you know that complex what is that event processing where they say that data is flowing. In SQL, what happens? Data is static. You keep on changing the SQL. In CEP, it's the reverse. SQL is static. Data is flowing through. Data flows through. Something happens. Depending on the SQL, it flows. Right? So that is the way we built it in terms of, and those are the entities we have separate: the rule entity, the trigger entity, the threshold entity separate, and the action entity is separate. Okay. Now coming to the ad tech is a very it's a different ecosystem. And the prime use case we were as data suppliers to create better addressability and targeting of the users. So here is the first time the variety problem hit us because we had to collect data from multitude of sources, anonymize them, and still ensure the downstream targets are achieved. Okay. So here is where the schema challenge really comes. Okay. Simple example: one data source will send male as young, capital. Another data source will say male is MALE. Another will say 0. Okay. So for them, 0 is male. And 1 would be female. Okay. So these kind of all hieroglyphics will come into play. So you need to invest heavily on the transformation and the validation. Okay. And all of these are timestamped. So I'll just give an anecdote in terms of in one of this thing. So you have these various creatures which can come. This was classified by one of my other known person in Bright Field.
Okay.
So you have data value, you have a timestamp. Okay. So first creature which can hit you is the undead creature. Okay. You have the data value but no timestamp.
Okay.
Second is you could get a ghost. You just get the timestamp. There's no data.
Okay.
You have to do something called imputation.
Okay.
The third creature which can come is the Frankenstein.
Okay.
One source says this is male, another source says this is female. Okay.
Okay.
Two values, but same data point.
Okay.
Okay. The next one is you could get something called the zombie. Okay. So that means you have an invalid timestamp. It could be the timestamp would be post 2025 data point will come now. That is the zombie. Then the last one which would come is there is an invalid data value. They are supposed to send a string value. They are sending something else there, right? So that is the toxic data, or we call it basilic. So you need to have these classifications, and for each of these you have validation layer and how to manage that. So yeah, I just thought I'll touch upon these.
No, it's amazing. I think a lot of things to think through, right? One is the validation framework itself in terms of how you do it, right? And then touched upon the variety of different data and making sure it does. Right? So, I think amazing. What are the things that are you have done enough in terms of data governance? You talked about all these things. What are your top priorities now in terms of the current stuff that you're working?
Sure. So, like anyone else in planet Earth, we are also on the AI game.
Awesome.
I think so. One thing which we realized is it is the most context-hungry creature. Okay. You understand what is context. Right?
Yeah.
Unless you give it the right context, you can
Correct.
throw out whatever it wants. So, so one of the major work going on is the context refinement. Okay. So that is one major work. Second thing is, given we operate in EU and we also operate on sensitive data sets, we are doubling down heavily on our privacy stories.
Okay.
And third thing is, of course, we are looking at always new paradigms of how we could make the processing efficiency much better. So we have done some real good work in terms of bringing the processing efficiency, both in terms of SLA throughput as well as the cost of this thing. So that is going to continue because frugality is one of the name of the games.
Yeah.
So that is also going to continue. So these are the top three items. Which is
awesome. I have one question. Maybe the last question. Is there any metric that we can do? For example, you talked about petabytes of data. This is what it is, right? Like, how do you measure in terms of the frugality, right? A petabytes of data might be costing you millions of dollars.
Yeah.
Somebody might be doing $100,000 or $200,000 with GBs of data.
Right.
Are there any metric that you are looking at to optimize and say that, hey, this looks normal?
Right.
So in terms of data throughput or in terms of others, right?
Sure.
Are you trying to get to that point where this is my system is efficient?
Yes. So the primary two variables what we have experimented and figured out is the size and the speed. Okay. Size and the speed, variability with time. And generally, if time goes down, cost goes down. Okay. So this is where I would stop in terms of what we're doing, because in a way I'm trying to patent that. Whatever we are trying to do there.
Awesome. I think thanks for coming here. And thanks for coming to the office and then having the podcast here. Pleasure meeting you.
Same here. Thanks
Thank
for
you.
inviting me.